So, so let's begin. So a few points which I've put together for today. So not just today, but today and tomorrow, and that is something which we'll go through. So firstly, understanding what are numerical methods and why do we require them. So have you? Uh, so maybe what could be the usage of these techniques? Now, why do we require numerical methods? Any idea? Or maybe have you used a numerical method somewhere else? Maybe not just in finance, but any other application where you might have used some technique of solving something. So maybe in your econometrics class or even in your other subjects. Or maybe even as a part of your advanced analytics class, which you guys have. So I think even there something might have been covered. Okay. So the idea is we use a numerical technique whenever we don't have a closed form solution for our consumption. So either we don't have a closed form solution, or the solution is such that it would be much better to solve it numerically rather than use the closed form solution, which could be slightly messy to solve. So that way, and these are a couple of intuitions as to why numerical methods are required. And when we say numerical methods, you can think of numerical approximations because we don't know for sure what would be the value of a certain product. We are trying to estimate the value for something. And that's why we say it's an approximation. We don't know with certainty, but we are confident to a significant degree that this could be the value for or fair value for a certain product. So generally, whenever you don't have a easy or a closed form solution, you have to go in for a numerical technique. And unfortunately, in most applications in quant finance, you won't have ready solutions. Now, Black-Scholes is just one of those easy ones for which you have a closed form solution. But otherwise, generally having a single formula to give you answers for something that may not be available all the time. So at that time, we need to go in for something like a numerical approximation. So that is what we are trying to understand through this discussion. So maybe a very simple example of a numerical approximation can be, uh, or maybe any example on root finding, which you can think of. So whereby you might have solved for roots and then you say that this is the solution. So anything which you can recollect. Okay. So a very simple root finding exercise can be a simple equation: ax squared plus bx plus c. So there we had a ready solution, isn't it? We had a minus b plus or minus root b square minus 4ac by 2a. So this was like a ready solution for this equation. So using this, we could get a value of x. So we used to say x equal to plus or minus something. So there used to be two roots for this equation. So that way, and this was a very simple root finding exercise. Anything in finance which you might be able to relate now, because now you know what root finding is. So maybe could you extend it to a certain application in finance, or maybe any other domain as well? Okay. Can I say that solving for YTM for a bond could be a root finding exercise? So when I say YTM, it's the same, yield to maturity. Would it be similar to a root finding computation? So let me write this. So so let's say I have a 3-year bond. Let's say it's an annual coupon paying bond. And let's take some value of coupon C and a face value FV. Simple bond pricing equation. Of course, we will do some review on fixed income at a later point in time before we get on to anything of or any interest rate products. But till then, and we can work with this. So we have this very simple bond pricing equation. So we know that bond price is nothing but present value of its future cash flows. Now we have a bond price. So let's say it's a quoted bond. So bond price P is known to us. Let's say it's a fixed coupon bond. So the coupon will again be mentioned as a part of the term sheet. So we know that for sure. Face value will be mentioned in the term sheet. So that is known as well. Now only thing which is unknown is Y. And we are trying to calculate this value for Y. So can I say this is very, very similar to a logic of root finding? Would that be the right way of putting it? So can this be root finding or not really? Because here basically what we do is we know everything but we don't know why. So we'll simply expand these brackets for y and then we'll solve for y. So we'll move everything on one side and we'll keep y on the other and we'll try to find the best fit value for y. So here you see there is an equality sign. So this is an important relation because this will help us arrive at the solution. So there are a couple of ways to do this. So if you decide to do this through Excel, you may have to use goal seek. So I'm sure you guys must have used goal seek before. Something which comes inside your Excel solver.
No, sir, we have not used this.
Okay, okay.
We
So
have used the Excel solver, but not this goals.
okay, okay. So goal seek actually helps you figure out a certain value which will help you balance a equation like this. So basically through goal seek, what we do is we give a certain start. So we'll define this equation in Excel and we'll give a certain starting value for this y. So maybe something like a zero point 0.1, just some arbitrary number for Excel to begin with. And then we tell Excel to solve this equation. That is, we tell Excel that you have to solve this equation in such a way that this equality is maintained. And for that, Excel will go through a series of iterations. And after going through the series of iterations, it will come up with a certain best fit value for y, which will help us balance this equation because there will be one specific value for y, whereby the right hand side will be equal to the left hand side. That is, the equality of this relation is maintained. And this is something which will happen through trial and error or what we call as iterations. So even when you run a goal seek algorithm inside Excel, you'll see that it will keep on changing the values for y until it converges onto a certain value for y, which will balance this equation. And then it will display that as a result. So even when you see the output of a goal seek method, it will show you the number of iterations which Excel has done along with the best fit value for the parameter. So this is how you can do root finding through Excel. So are there any similar or are there any libraries which are there in R programming which help in root finding? Or any other scripting tool? Because Python I know, but R does R programming have something like this? So maybe did you have to use this as a part of your other subjects whereby you used R?
No, sir, we have not like there is we just use the formula for to calculate the bond, not just any integrated library for this, sir.
Okay, okay, okay. So I'm sure R will have something, but in Python we have scientific Python or SciPy. So SciPy helps in such root finding computations. So techniques like Newton-Raphson or even maybe a bisection, etc. Now, all of these are encapsulated inside scientific Python or SciPy library. So that way, it becomes a very convenient exercise to solve for such computations because you have these advanced numerical techniques which are already coded in a certain library. So you simply have to call the library and use it. So even for solving the above equation, we can use a Newton-Raphson scheme. Again, we don't have to write the Newton-Raphson scheme because it is already ready in a library. You simply call scientific Python, you call the required function on Newton-Raphson, pass the required parameters, and you have the answer. So that's how easy it gets. So that way, numerical techniques can make things comparatively easy. You can do this through Excel as well, but Excel at times can be a little painful. So maybe using a certain numerical method might be a good idea. Yeah, so this was one simple example of root finding. So that way, there are multiple financial products whereby you may have to use some kind of a numerical method to solve things. So a few financial instruments which I can think of. You'll have to do it for options, any kind of structured varieties or structured products, and any other places, and any kind of advanced analytics which you're trying to apply to financial instruments. But I would say is the major area whereby numerical techniques will be used very often, because otherwise, for other simpler products like forwards, futures, etc., we have an explicit formula which we can directly use. Now, honestly, you don't require a numerical technique there, isn't it? Because if it's a forward contract, it's nothing but plain discounting. So generally, those places you numerical schemes might not be required. But for options or structured varieties, whereby you have a difficult looking partial differential equation which you're trying to address. Now, that is something which might be difficult to do through Excel, but maybe some kind of a scripting tool or some numerical method implemented in some way. That would be an easier way to solve that. So, these are a few popular products whereby numerical methods get used very, very often. So, starting with the first, Monte Carlo simulations. So just to give you an idea of simulation, let me switch to the whiteboard so I can show you the explanation there. Then we can do a simple hands-on as well. So let me just switch. Okay. So as a part of your business analytics class or your analytics class, did you guys do simulations at any point in time?
No, sir. As of
So we
now,
once ran a Monte Carlo, but it was a very so basically, it wasn't really explained to us. It was just an elaboration.
Okay. Okay. All right. Okay. So we'll talk a bit about, and this is the same for both batches. So this analytics subject is there for financial economics and international business both, is it?
Yes, sir.
Okay, okay. All right. So we'll quickly understand what is simulations and how and why it's required. We'll do a hands-on as well. Okay. So when I say simulations, what I'm trying to do is I'm trying to have as many plausible asset price paths, which can happen from now until my horizon time point. Let's say capital T. That is because I don't know for certain, right, where the asset price is going to go. So I'm trying to have as many plausible scenarios which the stock price can take from today until maturity, so that I can use it as a good estimate in order to use it for my downstream calculations. So there can be a variety of downstream calculations. We'll talk about that as well. But your simulation could look something like this. So let's say this is t equal to 0. Let's say this is t equal to capital T. Let's say I am standing on S0. This is today. And when I say simulation, I'm trying to build something like this. Then, so this could be one path. Now, again, there is an approach to construct this path. Now, I can do it in one shot as well. So we'll talk a bit about that approach later on. But for now, when we do it in Excel, what we are going to do is we are going to split this path into smaller parts. So you can imagine that I am dividing this into multiple pieces and I'm trying to fuse them together in order to build a path. So we can imagine that this is my small time step dt. So I'll be using the same equation which I had written earlier. So in our previous class or before that as well. So we have the ds equation. So we have ds equal to rs dt plus sigma s dw. So this is something which I'm trying to simulate because this is the process for my stock price. And let's say I want to simulate the asset price path, that is the stock price path, so that I can use it for a variety of applications. So dt happens to be my very very small time step which I'm doing, and over this time step I'm building a very small increment in stock price ds. So over this dt I am working only on this small section. So I'll just highlight that section maybe in this green oval. So I work only on this section. Similarly, let's say I'm looking at this step dt. So even in this step dt, I'm trying to work on a very, very small value of ds, which is encapsulated within these two red boundaries. So that way I'm having multiple values of dss, which I'm trying to fuse together so that I can have my entire stock price path done. And this is how I can use this equation in order to simulate one asset price path. So any questions on this?
Isn't a sir, isn't a Monte Carlo supposed to be multiple or like several simulations and not just one?
We'll talk about that, yes. So we'll just focus on one path because the methodology is similar for other paths also. So is the first path okay? I mean, any questions? Because otherwise it's just a repetition for other paths. So if you have any queries here, please bring it up now.
So is it like Brownian motion that you explained earlier?
Absolutely. So this is GBM. So the DW portion is bringing in randomness. So we are trying to, this is my stock price random walk, which I'm trying to simulate. So yes, there is definitely Brownian motion here because DW portion takes the Brownian motion here. So yes. Any other queries? Okay. So this is one path. Now, once I'm clear with one path, I have to just repeat the same thing n number of times. So this is path 2. Let's say this is path 3. And let's say this is a path n. So maybe I could have path 1, path 2, path 3 up to n. So we'll talk a bit about this as well. How many number of optimal paths, etc. We'll talk about that. But what I do is whatever things I have discussed for path 1, I will replicate that for path 2, 3, and so on up till path n. So that way I have n number of paths which I'm generating, and it is always good to have more number of paths because that way we are able to capture as many plausible scenarios in the stock price from today until expiry or until my time horizon point, capital T. And that way, I'm able to capture as many scenarios, which is the expectation, because I don't know for sure which path I'll be taking. So the more the number of paths, the higher would be the estimation of, let's say, the option price, which I'm trying to imply through this simulation exercise. And and this is the brief idea behind Monte Carlo simulations. Now, once I have these simulated paths ready, I can use it for a variety of applications. So a few applications can be option pricing, something which we'll do anyway. Then I may also want to use this for my value at risk calculation. So we'll talk a bit about VAR at a later point, but it can be used for VAR as well. This can be used for stress testing, something which a regulator expects as well. Anything else? Pricing, VAR, stress testing, yeah, and maybe anything else. But otherwise, these are the three applications which come to my mind right now. So once you have a simulation done, this simulation can be applied for a variety of applications. So when I say pricing, you can price it for a variety of options as well, something which we'll do in a simple Excel computation setup also. So any questions in this? Does this look okay?
Sir, will we be using Excel to calculate this?
Yes, yes, we can do it in simple Excel. Yes.
Okay, sir. Thank you.
Okay, so going back, so just walking you through the algorithm which we are planning to implement. So let me just reshare screen. So these are the steps which I'm planning to implement for the Monte Carlo pricer. So I'll take a, a certain option which I'm trying to price. So be it a call or a put option. So firstly, we'll generate a asset price random walk, or the first path from today until my time horizon point up till capital T. So this will give us one realization of the asset price path. Once this one realization is done, I can calculate the option payoff at maturity for this path. Then I repeat this step number one for multiple such paths. So again in Excel, once I write the formula once, I have to just drag it afterwards. So that effort again gets saved. So once I have my one path ready, I can use it for multiple number of paths later on as well. Again, for each of these paths, I'm going to calculate the payoffs. So for every path, I need a certain payoff. Let's say I call it a payoff of I, so that I keep I as the number of paths. Then I compute the average payoffs. That is, after I have these individual paths, I'm going to average them together. After averaging, I need to take the present value, because finally I'm interested in the MTM for the option. So that's why present valuing of this average payoff is required. And this will give me an option MTM as of that day. So I can use it for a plain vanilla European option. We'll also try to do it for a barrier option as well. So does the approach look okay? So just to summarize, we start with one path. We simulate the entire path. We repeat this process for, let's say, 100 other paths. Imagine that 100 is a large number, and we simulate it for 100 paths. Now for every path, I'm going to apply my payoff condition. So depending on whether it's a call or a put. So either use a max of S minus K or max of K minus S. Then average the payoffs across all the paths, present value them, and you have the option MTN. So that is what I'm planning to accomplish. So any questions in the approach?
No, sir.
Okay, so can I request you all to open a Excel sheet? So plain fresh Excel should do. So I'll also do the same thing. I'll need to stop the presentation. Okay. I'm a screen share. Yeah, from here I can open Excel. Okay. Okay, so Excel is opening. Uh, yeah, someone raised their hand. Yeah, please go ahead. I'll just plug in a few sample inputs which I require, and we can use the same. Hit them. Let's give the file as well. Okay, so let me just share this. So it's just a blank Excel along with a few sample inputs which I've taken. So these are my inputs for today. So I want to do it. So my asset is currently at 100. Interest rate is 5%. Volatility is 20%. Expiration is 1 year. I've taken a very small time step, and I've taken a strike of 100. And I would like to price both a European call and a put option. I can also do this for a barrier option at a later point. So we'll do barrier also later on. So since the setup is ready, we can apply it for barrier also. So you can request you to use the same inputs now, and then we'll begin the simulation. So once everyone is done, let me know, then we can start.
So VOL stands for volume,
No, this is volatility.
volatility, sir.
What's the barrier option?
So we'll talk about barriers. So request you to hold on to barriers for now. Maybe I'll just delete this to avoid confusion.
So what is the time step there?
So time step is 0.01. So I have taken a very small time step. So this is my DT. So you can imagine that these are my small time increments. So we have all the parameters which will require for a certain European option or even for a barrier option. So these inputs should suffice. So if you see, I have those 5 inputs which I require for pricing any option. I have stock price, interest rate, volatility, capital T, time to expiration, and the strike price K. So once everyone reaches here, let me know. Then we can proceed.
Done, sir.
Okay. All right. So let's begin with the time steps first. So let me write time, and this is 0. Then I just add 0 plus my time step. Just freeze this F4. Okay. And let me just drag this below. So does this get incremented? Yeah. So I have to take this right until expiry. So maybe 100 odd rows, I guess. So is everyone familiar with this notation? $V, $5. What does this mean?
Yes,
Sir,
sir.
you
You
lock
make
the
it small
particular
step.
cell.
Correct. Absolutely. And how do I do that? Do I write dollar, dollar? Do I hard code that, or is there?
F4.
Very good. Yes, good. Right. So for those of you who may not have used this earlier, this is used for freezing the cell. Because if I don't freeze the cell, when I drag the formula, the cell reference also goes down. So I don't want that to happen. I want to stick to the same time step. So that's why this dollar dollar thing is required. So I have my entire time step. So my horizon is 1 year. So I have these from 0 up till 1 year. Next, let's write 1, my simulation 1. So I have my today's asset price. I'll just link it to 100. I just do a F4 again. Either a F4 or a function F4. So for some laptops, you have that function key which is there. So in that case, you need function F4. So for me, I need that. Guys, any idea how I can get rid of that function key? I don't want to use function because it gets very annoying at times. I just want to use those function keys. So I'm using a HP laptop and a Windows system. So any idea how do I get rid of function? I don't want to use that Fn. I just want to use F1, F2, F3.
So
So any
directly you can use, if you use Fn key, then it will use the function.
but actually, if I just press those function keys, so let's say I have this volume on F8. So if I press F8, it changes the volume. It doesn't do the functionality
So
for
then
F.
you might want to use with Fn because it works conversely for other keyboards also. I have Fn key, so I have to use it for other multi-purpose keys.
But if I want to get rid of Fn, if I don't want to use Fn, is there any way to do that?
Sorry, sir, I'm
Sir,
not
I
aware of
tried
it.
this once.
Oh,
I have a similar laptop, it seems. You need to go into the system settings, but even I am not able to find that particular setting
oh,
where you can disable it.
okay, okay. Because otherwise, I mean,
Basically, you just
especially the
reverse the
thing,
function. Basically, you just
especially,
reverse the function. So whenever you press Fn, Fn will enable you to change the volume.
oh, okay, okay. Okay,
You
so
can
let
reverse it, but you cannot disable it, as far as I know.
Oh, okay, okay. Okay. Because actually, that stepping through the code becomes difficult. You have to press Fn and then press F8 or F9, whatever. All right. Okay. For now, let it be. Let me check that. Now we can do the simulation. So equal to. So let me write this first, and then I'll tell you what I've written. Into 1 plus R dt R into dt R dt plus sigma dw. So sigma F4 and dw will be phi root dt. So s square root of dt into random numbers, right? So norms inverse random numbers. closing bracket. Yeah, like this once. See, is a reasonable. Yeah, looks to be. All right. Yeah. So what I've done here is I have simply written that ds equation in one form. So let me show you what I've done. So although the formula may look messy, so let me just I can just maybe ping this formula so that it becomes easy for you to refer. Just go to the chat. Ping this. So I'll tell you what I've done. So let me just switch to the whiteboard. Stop sharing and reshare. Okay, so what I've done here is I've used this same equation. Only thing is the way I've written is S into 1 plus R dt plus sigma into dw. That is, I'm trying to have those smaller increments step by step. That is, I work on the first time step, I get to a certain value of the stock price. Then I build on top of this through the next time step, I reach this second point. Then again, I build on top of this, I reach the third point, and so on. And that is how I reach from S0 to ST. So that's how I can do it in individual time steps. So there is a way to do that in one stroke as well, but unfortunately, I'm not sure if it can happen in Excel. But in Python, we can do that. So maybe at a later time, we can talk about that as well. But for now, this should suffice. We are basically splitting up this. So the setup remains the same. Only thing is I have written this equation in a form which Excel will understand. So I continue to use the same random walk equation. So let me go back. And I write it just once. Subsequently, I have to only drag the formula. And these are random numbers. So if you press F9, so sorry, function F9. So these numbers should keep on changing because these are random increments which are happening. So you see this random function which has been used. This results in drawing of numbers from a standard normal distribution. And that basically introduces the randomness into the calculation. And I have 100 steps because I have 0 to 1 year. So this is my entire horizon. I can repeat the same thing for 100 steps. Imagine that I want to have 100 paths. So let's say I'll just increment this to 100. So first let me just drag the number of paths and then I'll drag the formula. So these are the number of paths. And let me, let me just see the column as well so that I can copy and paste the formula accordingly. This is column DA. Just copy and I just paste this thing until DA. So what I've done is it's a simple simulation. And advantage of Excel is I have to write it just once and then I have to simply drag the formula. I don't write it over and over again. It's an advantage because that way chances of errors are minimized. I have the formula, I just copy and paste it. So once everyone reaches this point, let me know. If you have any questions, also, I mean, please feel free to bring them up.
Sir, is there a way to lock these? Is there a way to log these values? Because what's happening now is every time I make a change on the sheet, these numbers keep on refreshing. And it
Correct. Yeah.
consumes a lot of system power. Yeah.
Yes. Yes. So actually, that's a good question. So Ali is a step ahead. So Ali, request you to hold on. We will talk about that. There is a point on this. Thank you for bringing it up.
Excuse me, sir. I'm having different value.
Yes, the values are going to be different. Now, none of us will have the exact same set of values because we have this random function which we're using, isn't it? So these random numbers are being drawn from a distribution. And for each one of us, that random number is going to be different. No two systems are going to have the same random number realization. So that's why your overall asset price paths are also going to look different. They'll be similar, but they'll not be the same.
Sir, how did you copy it into the 100 columns?
So I just select this range from 100 up till 1 year. I say Control C and I just do a Control V here. So let me just delete that. So if I delete this much, I select this much, I do a Control C. I select this remaining range until DA because DA is my 100th path. So let me go to DA. And I do a Control V. So simple copy and paste, Control C and Control V, which will drag the formula. So either you can do that or you can select that range and drag your formula through the mouse. Both works fine. And these numbers will be updated every time you open the sheet or press F9. So how to handle this thing, we'll talk about that. So Ali has already raised the point, so we'll discuss that. So let's complete this exercise and we'll talk about that. So everyone with me up till this point, can we proceed with the payoff and the MTM calculation? Anyone is facing any difficulties in this asset price generation? Okay. So now let me just scroll down and let's say I have a call option, a European call. This is my call section. I want payoff and I want MTM. So now payoff I know it's equal to max of ST minus K or 0. So this is my ST minus K is something which I've written about. So let me just scroll up. ST minus K, I'll just freeze that, control F4, a function F4 or 0. And I can just drag this right until the end. So simple, max of ST minus K. I'm going to require a discount factor calculation. So I can do that here as well. So DF equal to E raised to minus RT. So exponent minus, because I need a discounting term. I need present value of the option, right? So I need to present value this average payoff. So E raised to, so I just scroll up for a moment. E raised to minus R into E. This is my discount factor, something which I require for my present value calculations. My option payoffs are there, simple maxing condition. I can do equal to average of these payoffs into the discount factor. So this should give me my call option price.
So could you just show us the formula once again for
Yes.
the DF and the MTM?
Yes, so DF is plain E raised to minus RT. And payoff is max of ST. So if you see, I have taken these terminal stock prices minus K. So K is something which I have defined at the top, strike price, or 0. So max of ST minus K or 0. And MTM is nothing but simply averaging the payoffs into the discount factor. Discount factor because I want to present value things.
Excuse me, sir.
Mhm.
Could you please repeat what you've done from row 102 onwards?
So 10.
I,
Yeah.
I was busy with making the Excel sheet.
Okay, no problem.
Moving a little fast.
Oh, okay, okay. Yeah, we can go slow, no problem. Uh, so yeah, so everything clear up till row 102. So that asset price generation, is it okay for all the 100 paths? Is this fine?
Yes, sir.
Okay, okay, good. So next what I've done is I have calculated the payoff because I know my payoff condition is max of S minus K or zero. I am pricing a European call option. So my payoff is max of S minus K or zero. That is what precisely I've done here. So I've used the max condition, and if I do a F4, sorry, I do a F2, it's max of ST, which is my terminal stock price, 113, minus B6. So this B6 is nothing but my strike price, which is defined in my term sheet. So max of ST minus K or zero, which is the payoff condition for a for a call option, which is what we are trying to price right now. So I use this formula and I repeat it for each and every path. So I simply write it once and I drag it. So this gives me the payoff for each of the paths. And next, I need to take an average of these payoffs because I have those many number of paths. So as I mentioned, I would want to average my payoffs and then take the present value. So next, I take average of these payoffs, so average across each of the paths, and I multiply it by the discount factor. So the discount factor 102 is required because I want to present value things. So for that, I need a discount factor. I've used continuous discounting, e raised to minus RT. So this is nothing but e raised to minus RT. So minus B2 is my interest rate and expiration is the time. So e raised to minus RT. So you can just write e raised to minus R also, that T is not required because T is 1. But might as well we can keep that T because tomorrow if you are pricing a option with some other time to expiry, then that T should be taken into consideration. Right now, expiration is 1 year, so it won't impact the calculation. So I calculate my payoffs for each of the paths. I take the average payoff and I simply discount that in order to know the present value of the option payoff. So does this look okay? Any questions so far?
So can you show the formula of payoff once?
Yes, yes. Payoff is ST minus K or zero. So F,
Sir,
yes.
sir, in sorry, in cell D102,
Hmm.
you basically found a discount factor.
Yes.
But sir, I don't have EXPN on
No, no,
my.
that is something which I was using this Excel somewhere prior to this. So I was actually using this on one of my earlier projects. So I think I must have renamed the cell at that time. So
Okay.
I'm referring to time, right? So yeah. So
Yes,
this
sir.
is renamed as EXPN here. So that's why you see that
Okay,
EXPN.
okay, okay.
It's not required. I mean, you will get it as B4 or something.
All right, sir. So you would want us to write it as so equals to exponent bracket open uh interest rate divided by expiration
Um,
into.
Interest rates multiplied by the expiration.
All right, all right. Thank you, sir.
Yeah. So that way, I mean, many a times when I use Excel, I tend to give names to these cells because that way referencing them becomes easy at times. But again, not required, but something which I do on my other projects also.
So what's the reliability of any figures that we generate from this? Like for example, right now I have a I have a mark to market value of 10.2.
Correct.
But how reliable is this now? Like can I actually make a trade or actually enter into a trade based on this?
So the thing is, so that way you need to have sufficient number of simulations. So the idea is, since we don't know which path will be realized, we should have as many simulations as possible so that we get an option price which is very very close to the expected value of the option. So I think the reliability will be dependent upon how good the random number generator is So when I say a good quality random number generator, it should be such that your random increment should not get repeated. That is, a good random number generator does not repeat those random numbers over and over again. So that way, your sufficient amount of randomness is captured. So I think that is one. And the second thing is your number of simulations. Now, both of them are going to have an impact on the MTM. So I would say if you have sufficient amount of confidence on your random number generator, and if you can have a sufficient number of simulations, it would give you a decent enough estimate for the option price.
So then, sir, what do companies use? Do they depend on Excel or do they have some other tools of their own?
So there are other tools as well. So again, we'll talk about that as well when we talk of the how do you freeze on the number or the simulated numbers. So request you to hold on to that. So once we complete this, we'll talk about it. So at the same time, we'll answer your previous question as well.
Okay, sure, sir.
So for everyone, this value is going to be different. So don't try to match it. It cannot match because there are random increments here, and everyone's random number generator will generate a different series of random numbers. So we can never tally. Now, by fluke, yes, I mean the numbers may tally mine and yours, but otherwise it's not expected. Similarly, I can apply it for a European put as well. So let's try to do it for a put and a barrier, and then we'll come to the discussion. So a couple of points which Ali has also raised, and a few things which I want to add. So maybe let's complete the exercise first, and then we can discuss those things on the whiteboard. For a European put, again, approach would be similar. Only thing is my payoff changes. Payoff will be now max of K minus ST. It will be max. Let me just scroll up because my strike price is above. Max of K, I'll just freeze this. F4. K minus ST or 0. And let me just drag this ahead for all the 100 plans. So I'm simply changing my payoff condition. I'm not doing anything else. And applying a similar technique, let me just copy this. And I think I'll just change the formula a bit. So this is taking the average. Now let me just take this to discount factor. So this gives me the put MTM. Now I can apply this for a barrier option as well. So firstly, let me tell you what a barrier option is. So I think I'll need to switch to the whiteboard now. Show you what a barrier option is like. So an idea of a barrier option. So you can imagine barrier option is just one step ahead from a plain vanilla option. So this is also what we call as a first order exotic option. So let me draw one more input. So we will definitely require the 5 inputs which you have used for a European option. So the interest rate, volatility, spot price, strike price, time to maturity is required. Other than that, we also require what we call as a barrier level. So let me draw maybe the barrier level in the red. Let's say this I call as barrier level. Let's say this blue colored is my strike. And let's say this is my time to maturity. So let's say this is T equal to 0. And let's say this is T equal to capital T. So this is my total horizon. Let's say I'm standing here. Let's say this is S0 today. And let me draw 3 paths and then I'll explain you the behavior for a barrier. Let's say this is path 1. I can use 3. Path 2. And path 3. Maybe I can use orange. This is path 3. path, and this is path 1. So imagine that I have three number of asset price paths. Imagine three is a large number, or maybe we can apply a similar analysis for n number of paths. Now, focusing on the overall setup, now I have one more additional input which I have included here, which I call as the barrier level. So the line in the red. I have a strike level which is already given to me. I have a current stock price. So I start my simulations. So my first simulation, if you see, it begins from S0. And let's say I'm trying to price a call option. Let's say it's a barrier option of the type call, or maybe call or put. It doesn't matter actually. Fine, it will be. So let's forget about this. Let's forget call or put. We just want to understand the behavior for a barrier. So path 1, if you see this green line, this is my realization of asset price path 1. Now this green line is below the barrier level. That way, that means during the life of the option, which starts from t equal to 0 and ends at t equal to capital T, this asset price path has never breached the barrier because this green line is always below this red line. So that's why this path is still alive. This path has not got what we call as knocked off. Now, whenever you have a barrier option, you have a terminology which you call as a knock-off or a knockout, I would say. Now, path 1 has not got knocked out because we have a barrier level which is defined at a certain value which is higher, and this stock price path has never breached that barrier. Similarly, path 2 is also alive. That is, it has not got knocked out because path 2 might have breached the strike price. However, at no point in time during the life of the option has path 2 breached the barrier level. So path 1 and path 2 are not knocked out. They are alive. But we can't say that for path 3 because if you see path 3, the structure is that the stock price has risen beyond the barrier at a certain point in time and then it has come down. But the barrier level has already got breached once. And the nature of the barrier option is such that if your barrier level gets breached at a certain point in time, then you assume that that particular option path or that particular asset path has got knocked out. So that way, path number 3 has got knocked out because the asset price has breached the barrier level. And this is how the barrier option behaves. So finally, when I calculate my payoff for the barrier option, I will get payoffs only on path 1 and 2, which I'll use in my computation, but path 3 will get knocked out because so when I say knocked out, I'll take that payoff to be 0 simply. That will not be used in my computation. So does this look okay? So that way you can imagine a barrier option is very similar to a plain vanilla European option. Only thing is we have one added feature, which is the barrier option or barrier level. So if you ask me price wise, everything else remaining the same, that is the same issuer, same strike price, same time to maturity, same underlying. A barrier option is expected to be cheaper than a plain vanilla option. The reason behind that is because we have a barrier condition which is embedded. That means that investor is taking a risk on this product. So imagine that I am an investor and I have purchased a barrier option. Then I'm taking a risk, isn't it? Because if the barrier gets breached, I may not receive the required payoff which I'm looking at. But for a European option, that barrier condition doesn't exist. Now, since the investor is taking on a higher amount of risk because of this barrier condition, the investor has to be compensated for that. And that's why everything else being equal, barrier option is expected to be cheaper as compared to a plain vanilla option.
Sir, wouldn't be it be an outlier when we plot it on, say, normal distribution curve?
Uh, Sorry, I did not get your question. Could you elaborate that a bit?
Even I'm confused. If we plot the pricing on a normal distribution curve, wouldn't this the barrier options be an outlier compared to other?
Not really. So because what we're doing is we are simulating n number of paths, right? Now there can definitely be certain paths whereby the realize. So yes, I mean if you talk from an outliers perspective, I would not really call it as an outlier as such. Because finally you don't have a control on what random numbers are being drawn, right? So depending on your random number generation, your asset price path is getting developed. So based on that, you'll get to know whether a certain path is breaching a certain barrier or not. So I think that would be one of the ways of looking at it.
Sir, and one more thing, sir, would the barrier option have incidentally higher payoff because we are absorbing more risk?
Uh, Not really, because if you talk from a cost perspective, if so the example which I mentioned, so the investor needs to be compensated so that the barrier option is cheaper. So that way your payoff will be dependent, or payoff will be like a plain vanilla option, but with a barrier condition. So only in that case, that option will be cheaper. Because if you're compensating the investor for that barrier condition, then the option may not be cheap. Then it should be equivalent or maybe even expensive than a plain vanilla European option.
Okay, sir, thank you.
Sir, and what is the underlying usually for this kinds of products?
It could be either a stock or maybe even a FX or probably even a commodity price, etc.
So even for equity, these kinds of products are available. But again, I
Yes,
imagine these to be only
OTC, OTC, yes,
OTC only, right?
yes, yes,
Okay. Sir.
Sir,
yes.
sir, is there a difference in risk for path 2 and 1 because one is above the strike price and the other one is below the strike price?
No. So from a payoff perspective, if I take this to be a call option, then my path two is generating a positive payoff for me, but path one isn't. But both of these paths are alive. So that way, when I'm calculating my overall option pay or option MTM, both of these paths will be used in my computation. That's how I would look at path one and path two.
Okay, sir.
Sir, can this barrier be below the strike price?
Yes, definitely it can be. So that way you can customize the contract as per the requirements. So it can so that barrier level can also change. Your barrier can also be equal to or be very close to strike as well. So accordingly, your overall option cost will also differ. Since it's a customized contract, depending on what the investor demands, and you can structure a contract that way and use it.
Okay,
So
so one last question. I'm
yes,
sorry.
no problem.
Right now, what we did for what we did for the vanilla options is we just calculated all the payoffs and then the MTM, right? But then for this product, should we not also look at the probability of breaching the barrier?
So what we do is the probability is something which is captured as a part of your random number generator. So if you see the equation which we have used, we have that random function which is being used.
Yeah, yeah.
So that takes into consideration the probability distribution. So that way we are drawing numbers from a specific distribution. Now there will be one additional condition whereby I need to see if at any point in time from today until maturity, has the stock price breached the barrier level at any time? And if it has, I need to knock that path off. So maybe one small if condition would be required. And your probabilities are already being captured as a part of our current simulation.
Okay, sure, sir.
So if I switch back to Excel, and we can use the same setup because maybe we can decide on a certain barrier level. So let's say I want to have a barrier call with, let's say, a barrier level of maybe 110 or maybe 115. So again, I need to have a payoff first and then the MTM. So now in the payoff bit, I'm going to require a simple if condition to see whether I'm and what whether a certain path has survived. So I can have a if max of, so I don't need the terminal price, but one step below the terminal price. So up till 0.99, this from here up till my initial starting point, 100. If max of these values is greater than the barrier, and just freeze this. If it has breached the barrier, then 0, else it has survived. It is 1. Into, I have a barrier cause, right? So I can have a max of ST minus, I just scroll up, strike price is above, F4. What I've done is I have checked for the knockout condition through this maxing bit. So if at any point in time from any time in history, if so not exactly history, but any time during simulation, if I have breached the barrier level, make this flag as 0 or else keep it as 1. So if a path has got knocked out, the entire thing goes away. If not, this will return as 1 and then I have the payoff condition. So I can drag it here as well. Why are we getting negative values here? Oops, sorry. It's max of something or 0. I have not flowed it at 0. My apologies. Max of this thing or 0. Let's drag it again. And I have the MTM, which is similar. I mean, I just take equal to average into the discount factor. So similar to our earlier exercise.
So can you show the barrier CA formula?
Yes, yes. So let me just ping this as well. So the if condition checks if the barrier level has been breached at any time. If yes, then return a 0. If no, return a 1. So this helps me decide if a path has got knocked off or it is still alive. And then I simply apply the payoff condition, max of ST minus K or 0.
So can you show a formula in B111?
B111 is my, yeah, let me go back. So B111 is my barrier level. So I'm defining my barrier level as 115. So this is my barrier level.
Oh, okay, sir.
So, sir, in real life, how does this barrier option works? If like the price goes above the barrier, then what happens?
So if the price goes above the barrier, your particular simulation will get knocked out. So it will have an impact on your overall valuation. Now, finally, standing today, you're trying to estimate what the barrier or what the barrier MTM is going to be. And let's say my option has, let's say, 2 years to maturity. So through simulations, I try to figure out what could be the best estimate of the barrier option today based on whatever market information I have. So things like stock price, volatility, etc. And accordingly, I'll need to use this MTM to mark it on my books because finally I would have to have an estimate as to how much a certain option is worth. So I would want to know how much this barrier is worth. So that is where this MTM would be useful. So I can use this for marking it on my financial statements.
Sir, that is for the numerical example. I was asking, like, in case of call options, for example,
Mhm.
if we exercise the option if the price goes above the strike price,
Mhm.
then we exercise the call option. So in this case, what happens?
Correct.
In the ba-
So if you exercise it, anyways, if you're taking a plain vanilla European option like we have right now, you can exercise it at maturity. So at maturity, anyways, you'll be looking at if at any point your level has got breached. So if your barrier option has breached that particular level, then and you don't have, so finally at maturity you don't really have to do a separate payoff calculation, right? And you simply check your level on that day. Now if at and generally your barrier is designed in such a way that maybe up till one step prior you keep on checking the level. So that way, even if you see my condition, so this is like a typical structure which you'll observe. So right from today until maybe 1 day prior to expiry, I will keep on checking the barrier levels. So if at that point in time if on any day the asset price realization has breached the barrier level, then I don't receive any payoff. If not, so basically two scenarios. If I survive uh, until capital T minus one, that is my option has not got knocked off. That is because finally, as time progresses, I know the exact realization of the asset price, right? Because as time passes, I will have a closing stock price available for my comparison. So if that stock price has never breached barrier, then my option is still alive. And then on capital T, which is my time to expiry, I'll check whether that stock price is higher than my strike price, and it will give me a payoff. Conversely, if I observe that up till T minus one, that realized stock price has breached the barrier even once, then I don't receive any payoff.
Okay, sir. Got it.
Because right now, why we require simulations is we don't know what the stock price is going to be realized. As time passes, we have the realized stock prices or the closing stock prices. But until then, we need to rely on a certain model to estimate how much a certain option is worth. And that's why we are doing this exercise.
Sir, also one more thing. Sir, there's no payoff means no transaction happens in the end of the asset.
Yes, so no payoff implies so imagine I am a option buyer, so I don't receive any payoff from the option, but I have already paid a premium upfront to my seller. So that way, if you talk from my profitability perspective, that trade has resulted in a loss for me because I don't receive anything, but I've already paid a premium upfront.
Okay, sir.
So what's the rationale behind setting a particular barrier level?
So that will actually, so there are a few points behind this. So maybe one can be your option premium. So how much you're willing to pay. So that way, if you set a barrier level which is very, very aggressive or which is very, very close to the strike level, then that option will be comparatively cheaper. Whereas if the barrier level is sufficiently high, that option and then chances of breaching the barrier are lower. So that way, again, your pricing bits will change accordingly. So I would say based on investors' risk appetite, you can set a certain price level and then you can accordingly trade. So that way, your overall option payoff will be a function of uh, basically your payoff as well as the premium which you pay will finally become a function of where the barrier level is vis-a-vis your strike price. So I think
Okay,
from
sir,
a
sure.
trading perspective, that can be one of the ways of looking at it.
Okay, sure.
Any more questions on this? Okay. Now coming to the point which Ali had raised initially, so a very valid point. So every time I open this Excel sheet, or even if accidentally I happen to press F9, everything changes. Now my realizations of numbers are changing because these are random numbers, right? I don't have any control on them. So so in Excel, we don't really have a option to set what we call as a seed. So let me switch to the whiteboard. So generally for these advanced scripting tools, we have a seed feature which we have. So I'm sure R will also have something. Python has a seed. So there is a seed feature which is available in scripting. So you set a seed value, let's say to 100 or something. So once you set this seed value, that will ensure that whatever random numbers are generated, those will be consistent. So that way, if I decide on a seed value and then I do simulations, then every time I run the model, I will have the exact same set of random numbers which will be used in my computation. So for scripting, that is an advantage because you can set a seed and you can ensure that you are getting the same set of random numbers. As a result, your same option valuation gets repeated as well. But for Excel, that is not possible. Now, for the simulation which we have done, that feature is not available. So maybe what you can do is take a snapshot of this. That is, take a value pasted value for, or maybe take a, or just value paste these random increments, and then save it somewhere. So especially from an audit perspective, that is something which you should take care of because let's say your concurrent or internal auditors come up with or let's say they ask you for a option valuation and you give them this simulated value. So let's say it's 12 point let's say 12.45 or something. and you say that we have used a simulation engine and this is the MTM, and you just submit a report to them. So your auditors may say, fine, I mean, you have an option pricer, but we are quite inquisitive and we would like to know how exactly that works. So could you show us your model, please? So you'll be more than happy to do that because you have a model ready, isn't it? So you'll open up the Excel, but the moment you open up the Excel, you start getting new values. So you may press F9 multiple times, but you'll never be able to tally with 12.45. Now, the reason behind that is there is a random number generation which is happening in the background. Now, your auditors may or may not have an idea of what a random number is. Now, if they know what a random number is, they'll understand why there is a difference in value. But if not, they may blindly conclude that saying your model is incorrect. So, and they may issue a report saying that the model doesn't work as per expectations because they don't understand the theory behind it. Then you have to defend your stand, etc. So maybe from an audit perspective, if you're using Excel, then I would say value paste your numbers and save it in a separate Excel. So that way we have a ready working model. Maybe just make a value pasted copy of this sheet and save it somewhere so that if your auditor asks you for numbers, you can simply give them the Excel saying that this is the realization, you can check whatever you want. And that way, whatever number you have reported in your valuation report will exactly tally with your model. Now, if you're using Python or R, whereby you have these kind of seed features, then that will ensure that the same set of random numbers are being generated every time. And if that is the case, naturally your valuation will also tally. So if you're using Python or R, you don't have to make a value pasting thing. You just set a seed, and this will ensure that your numbers don't change. So especially from an audit or reporting perspective, that is something which you should be careful about. Yeah. So I think Adi, this was your first question. You had one more question, if I recollect.
Sir, I did, but even I don't remember what it was now.
Okay, because I mentioned that time that we'll discuss that together, but yeah. Fine. If you recollect later, please let me know.
Sir, he asked that every time the value changes, so what is the market? I mean, he asked
Oh,
something related to that. What is the um, credit worthiness of these numbers that are coming? Can we
okay, okay.
trade on these numbers?
I think that we partly discussed. So finally, as we mentioned the last time, we are using a same distribution every time. So that way, we are confident that we are using the right underlying distribution for drawing the random numbers. Now, what random numbers are drawn, that is beyond our control, at least for Excel. Maybe for something like Python, you can have some control on it. Again, now what random numbers are drawn, that is not in your control. But only ensuring that the same set of random numbers get used, that is in your control through that seed feature. So I think that is how you can justify your valuation numbers.
Okay, sir, sure.
All right. So we are at 10:55. So do you need a break for like 5 minutes and we come back?
Yes, sir.
Okay. Okay. So 5 minute break and we can resume by 11.
So the one thing you asked right now about not pressing the function key every time we press F4,
Correct?
for that you have to press function key and escape key simultaneously, and then
Oh, then it will. So I need to open Excel for that, or I can do it just like that also.
so you can test in Excel after that. So you
Oh,
have to press function S and escape key together. Then every time you will not have to press function key.
okay. So let me try that. This is interesting. Okay, let's press it together. Oh, it has opened some system information. Oh, I still have to use FL, but let's see. I mean, I'll check that out. It is
Okay,
something
so
to do with
in
file.
my computer it worked.
I see. Okay, okay. Well, but thanks. I mean, I'll just check that out. Okay. Yeah. So talking a bit of advantages and drawbacks. So again, I can stay on the whiteboard for the moment. Yeah. So advantages. Firstly, it's easy to implement. Then you don't require any and too much of programming skills for this. So no programming skills, I would say. No programming skills required. Also, chances of making errors is minimum. That is less error prone. So you really have to try hard to make errors in this. Yeah. And I think these could be a few advantages. Disadvantages is uh, it can be very intensive from a system point of view. So we'll talk about that in a bit. So it is system intensive. Also, another thing is handling American options can be a challenger. American options of the early exercise. Okay. So advantages are easy to see, and we saw how easy it was. We did not really require too much of programming. Honestly, it was just simple Excel formulas which we just used and drag dropped subsequently. But disadvantages are it is very very system intensive. So right now we have taken just 100 paths. But tomorrow, let's say you want to have 1 lakh paths, then your Excel can slow down drastically, or your Excel may fail to open also. You never know, depending on how much system specification one is working on. So that way it can become very intensive for the system to handle. So maybe you might want to have a stronger system if you want to use this setup for more number of paths. Next is handling early exercise. Something like American options can become a challenge because, again, it's not impossible, but it is slightly messy to do it for Monte Carlo simulations. So, especially whenever you have such American optionalities, etc., we prefer another technique which we call as finite differencing. So, something which we'll talk about once we complete simulations. But finite difference or FD scheme, as we call it, is another technique which we use for pricing options. So we'll see that as well. So maybe FD is something which we can discuss today, but implementation we can try out the next time. So these are a couple of disadvantages, I would say. Now, deciding on the number of simulations. So talking from your system optimization perspective, deciding on a value of n number of paths is very, very important. Now you need to figure out what is that best fit value for n. So do we have any computer engineers in our class? Or maybe anyone from computer sciences? Okay, because a couple of terminology they may be familiar. So one is what we call as a test server, and we have a production server. So a test server you can imagine is like a standalone system. So it doesn't have any relation with what your business is doing. So let's say I have a certain enterprise risk system, that will be hosted on my production server. So production is something which the business is going to consume. So whatever activities a bank does, they will be working on the production server or production environment, as we call it. Whereas a test server, this is standalone. So you can imagine this is like a separate system which is there for testing purposes. So whatever functionalities I develop, or if there either it's a new functionality or maybe there is an older functionality which I have enhanced. So all these things happen inside the test server. So before I put those new functionalities into production, I have to test them thoroughly, because any changes done to the model, they have to be tested before they can be consumed by the business. Because the thing is, a model developer, if he or she makes a mistake in the model, then the business will end up using a wrong model, which can be detrimental for the bank's business or any company's business. So whatever changes are made to the model, be it a new model or be it an optimized model, you need to run it thoroughly in a test test environment or the test server first. So there you can actually decide on choosing this value of n. So there you can compare system performance. So when I say system performance, you have to take into consideration the fact that it is not just you, but there are others in the bank who are going to use the same system infrastructure. So system resources are always limited, and and the entire bank has to work on that limited set of resources which is available. So it cannot happen that one team is consuming more than a lot or maybe a significant portion of that system resources, and other teams which are handling other mission critical activities have to take a hit for that. That is not acceptable. So you need to optimize your value of n, that is your number of simulations, such that your model performance is good enough, your prices are efficient, but at the same time you're not really impacting the system drastically. So when I say impacting the system drastically, that implies that your simulation should not have a detrimental impact on other teams businesses also. So that should not happen. So that is how you can decide on a value of n. So anyways, when you're working in a test environment, that and that is like a standalone thing which does not impact production. So other teams will not be impacted by your testing. So do comprehensive testing in the test environment, and decide on what is the value of n which is optimum from accuracy as well as from system efficiency perspective. Once that is done, you can push this patch into production. So any changes which you do, you say that you can push that into production at a specific time. Now, again, when to push that into production is a subjective decision. Uh, what banks will generally do is any new feature or new model which has to be pushed, that will be done on weekends. Because if something goes wrong or if the production server crashes, then on the weekends there is no business which a bank does. It's a holiday. So that way, if something goes wrong, you still have your technology team has time to recover. So that way, new functionality generally get pushed on weekends. Again, avoid pushing new functionalities on quarter ends or year end dates, because these are the dates on which, because for these dates your numbers are going to be reported to the regulator, auditors, your board, everyone. So that way, if something goes wrong on your quarter end or maybe year ending date because you have pushed a new model into the system, that can cause a havoc. So avoid doing that. So in case, let's say you're on 21st of March and you have developed a new feature and you want to push that into production. So just hold on to that. Don't do it for the next 10 days. Let 31st March pass. Let the system generate the required closing numbers for 31st March, save it somewhere, and then push it into production. So if something has to go wrong, fine. After 31st March, you have time for recovery. But if your 31st March reports are incorrect, then that will have regulatory as well as investor repercussions for you. So always these kind of things are something which banks are very, very careful about whenever you are to push something new into production. So always remember that these are the two environments which are there for your consumption. Do not make changes in production, because any changes made here without testing can be detrimental. And there is an audit trail as well. So everyone knows who has done what. So that way no one can hide that. No one can say that we haven't done anything. That's not possible, because your login ID will get saved in the audit logs. So to avoid any problems, I would say do comprehensive testing in the test environment. And once you're confident, move things to production. Choosing the value of n can be just one of the activities. But other than that, whenever you're developing anything new, always do it on the test server, never on the production directly. So, any questions on this? Also, I mean, one popular application of option or this kind of simulations can be index-linked options or index-linked debentures. Have we spoken about index-linked debentures before?
No, sir, we haven't.
Okay, okay. Index-linked products. So one popular example in India is a NLD, which we call as a Nifty-linked debenture. So we can imagine this is a combination product. So you have a bond plus an option. So that way, I would say it's a hybrid instrument because you have fixed income and you have derivative, which is being combined. And generally, these are products which NBFCs or fund houses may offer to certain set of investors, and they'll not be offered to everyone because the ticket size for these products is high. So I think it could be a few lakhs, or maybe 20 to 25 lakhs can be like a ticket size for this. And the holding period is also significant. So that way, the holding period is like 2 years. So up till that time, you're during that time horizon, investors cannot withdraw funds from this investment. So that is something which every retail investor might not find very palatable. So that is something which is popular with HNIs. The way in which this is structured is you have a bond portion to this. So you can imagine this bond is just like a zero coupon bond, a ZCB. Whereas the option, this is something which is interesting. Now, bond portion is easy to price. It's just fixed income. You can use any bond pricing calculator to do this. So has fixed income mathematics been covered for both financial economics and international business? So
Not for FE.
okay,
No,
okay,
we
and
covered the basics of bond value calculation. Very
okay,
basic.
okay, and for the international business class, for IB class, did you guys have anything on fixed income securities or bond markets in general?
No, sir.
Okay, okay, all right. So we'll talk a bit about bonds as well subsequently because we'll require bonds when we discuss ideas of bootstrapping, etc. So for the FE class, since you guys have been introduced to the basics of bonds, was the concept of spot rates, implied forwards, etc., covered as a part of your earlier subjects?
No, sir,
Something like
implied forwards was not covered, sir.
okay, okay, all right, no problem. So that is something which we'll cover subsequently. For current discussion, this is not required, so don't worry. So from a pricing perspective, bond pricing is pretty straightforward. We'll do that in detail later on. But for now, imagine that we have a bond pricing calculator and we have something to handle this ZCV portion. The challenge can be on this optionality part. So imagine that in my term sheet, following terms are given. So let's say I have this time steps which are, or I would say observation dates, I would call it. So observation dates are respective T's. So maybe observation date as T1, T2, and T3. Let's say I have a certain condition which is given. And based on that, I have a certain payoff which gets calculated. So all of this is in your term sheet. So is everyone familiar as to what is the meaning of a term sheet? Any trade has a specific term sheet. Have you? So has this been covered in any of your other subjects?
Sir, it's a document that shows all the conditions of the option. For example, strike price, interest, like
Correct.
your maturity dates, etc. Everything.
Correct. Absolutely. Yes. So just for the benefit of everyone, in case IB class has not covered this, a term sheet you can imagine is a legal agreement between two parties. So I would have two party names, party A and party B. We'll have the description of the product, then the terms specific to the product. So what will be the underlying, what is the strike price, what is the time to maturity, etc. And certain other conditions also. And in the end, you have signatures from both the parties. So this becomes like a legally binding agreement. So in case the parties have to fight this out in the court, this becomes a document which they can use for that particular litigation. But anyways, term sheet is something. So litigation is the worst case scenario. Other than that, as well, term sheet includes all of the terminologies which are specific to a certain trade. So once you go to the term sheet, you know what exactly a certain derivative transaction looks like. So similarly, for a NLD product as well, we can have a term sheet, and within the term sheet, we'll have a certain conditions which are defined. So let's say I call my Nifty as N. So let's say N is a short form I call for Nifty. So my condition could be that if at observation date T1, if N is greater than 10,000, I receive a certain payoff, let's say X1. Now, if at observation date T2, if N is between 10K and 15K, I receive a certain payoff. I'm just making up certain conditions right now. But in reality, you'll find something similar. And if the Nifty is greater than 15K but less than, let's say, 18K, I receive some payoff Z1. And this T is what these are what I call as my observation dates. So I could have this table which is given to me. That is, if at observation dates T1, T2, and T3, if these respective conditions are being met, then I receive payoffs X1, Y1, and Z1 on this particular option product. Now, standing today, I don't have a clue as to what the Nifty closing price is going to be at these respective observation dates. No one knows, isn't it? Because if we know that for sure, then we can make a lot of money. If someone knows with certainty as to where the Nifty is going to close at a certain observation date in the future, then they can make a lot of money in a very, very short period of time. But no one knows that for certain because there is uncertainty involved in the way in which your underlying asset behaves. That is the randomness principle. So for pricing such an option, using simulations can be one of the techniques. So imagine that I have this option for a period of 2 years, maybe, or maybe let's keep it as capital T. And let's say this is I just keep this a small t. So small t will keep on changing. Now let's say this is 0 and this is capital T. And here. So let's say currently the Nifty, I can call it as, let's say, N0. Now, I use a simulation technique similar to what we have done some time back. So I can have various paths which are being generated. So maybe 1, 2, 3, maybe 4, or N actually. So let's call them as 1, 2, 3, up to 10. So I have N number of paths which are being generated here. Now, what I can do is I can take a cross section of this. So let me draw those cross sections here. So let's say this is cross section T1, this is T2, and this is T3. Now, these are my observation dates, you can say, which are given in my term sheet. Now, I want to know, and maybe I can call this as N1, N2, and N3 to differentiate them. So what I could do is I can look at my cross section T1. I'll look at all of the paths which are there. That is, focus on this blue colored box and focus on these blue crosses only. So I'll take these respective prices and maybe I can take a simple average. So I can take the asset price levels at these points. I can take a simple average and call this average as a proxy for N1. Now I can either do an averaging or any other technique which I want, but averaging is easy. So that's why I've taken averaging here. Similarly, if I had to know what happens at observation date T2, again, I do the same thing. I take average of these paths and I can have a proxy for N2. And similarly, I can have something for N3 as well. Once I have an estimate of N1, N2, and N3, I simply plug it in these conditions to see if any of them have been met. Those conditions which are met, I take this payoff into consideration, and those which are not met, I don't take any payoff for that particular observation date. And based on that, I can figure out what could be the value of my option portion. And once I combine bond plus the option, I get the MTM or the present value of this Nifty linked debenture. And this can be one of the applications of Monte Carlo simulations. So any questions on this?
So, sir, for this, the payoff and everything happens instantly, I imagine, right? Because it's eventually just a simulation. Or do you
So
actually have to wait till maturity?
So generally, you'll wait till maturity because again, that will be dependent on your terms and conditions. If your terms say that once a certain observation date has passed, that is something. If there is a positive payoff which has to be paid out, then it may be immediately paid out then, or maybe the agreement could be such that the investor would say that fine, maybe invest those proceeds at risk-free rates or somewhere, and then maybe pay me in the end. So that can be customized as per the requirements. Any other questions? Okay. So that way, those of you who end up in the NBFC, there is a good chance that you may get an opportunity to work on Nifty linked or even basket linked debentures. So basket linked debenture can be a combination. So something like a Nifty and BSE Sensex, that is something which could be used as the underlying, and that is what you can use for your simulation purposes. Or even if you end up in one of these consulting firms. So those of you who are joining any of these big four firms, if you are joining their valuation practice, then this can be one of the products which can come for your third party valuation or maybe as a part of your audit valuation. So anyone joining Deloitte India or maybe any of these India practices, not the US one. So any of these big four India practices, because those guys have specific valuation teams. I'm not very familiar with the setup of these US offices because I've never worked on them. But in India, we have something like this. But it doesn't matter. Even I think, even as a part of your global offices, so either as a part of KPMG's KGS or maybe even for Deloitte's US offices, these are products which may come up because finally your American teams might have these products on their books. So let's say you're working with an audit team in America and they require your support on valuation, because generally the way in which things happen is, especially for these big four, is you have a large set of audit customers, and these audit customers might have something similar to these things on their books, and your audit team, since they have to give a sign off on the financial numbers for the client, they may want a comfort on what is the valuation for these products. So at that time, they approach valuation teams within the enterprise to come up to give them some comfort as to whether the client valuation is in line or are there any issues. So that time, audit and advisory or maybe valuation teams combine, and valuation teams are responsible for giving the valuation numbers. Again,
Sir,
yes.
uh, sir, since I have placed in Deloitte USA advisory role, sir. So what will I will actually doing there? Like, so what is the main task for the advisor, sir?
Uh, so I think that will depend on the team which you're joining. So advisory could either be valuations or company valuation or probably corporate finance, etc. So I think based on the role which they have offered, that responsibilities will change.
Okay, sir.
Again, if you're a part of valuation team who is giving a sign off on such products, then be careful when you're issuing a report for such products, because these can be slightly tricky products to understand and to price as well. So as a part of your report, you should always have a bifurcation between the bond and the option price. So many times let's say you're verifying your client valuations, and let's say your client has given you a total product valuation as V1, and this is all that they've given, and you similarly just calculate V2, which is the entire product valuation, and you compare V1 versus V2. But this is something which I feel is an incomplete way of looking at such products. So can you guess why I say that such comparison is insufficient? You need something more to give comfort on this valuation numbers. So what could be the reason behind this statement? So V1 and V2 is my entire NLD valuation. So I have one single number which I'm comparing between me and my client's MTA. So there can be potential problems which can come up later on. So what could be those?
Sir, eventually this is just a sequence of randomly generated paths, right?
Hmm.
So how can you eventually, there can always be a number of simulations that you do, but eventually it is still a random generation of things.
Okay, so correct. So that
That
is
way you can
something.
always,
Okay.
you or your client can always argue, okay, what if we run it once again, or what if we, I don't know, I'm not sure how exactly you can go about it,
Okay.
but I would eventually still have a question mark as to, what is the reliability of whatever figure I'm getting.
Okay. Okay. Oh yeah, that can be one point. Yes, and so that's why you should have as many simulations as possible, so that you are trying to have as many plausible asset price paths into the calculation. The other thing is from the accuracy perspective. So many a times it can happen that there can be compensating errors between these two sections, bond and the option. So let's say the client's valuation is such that the bond pricing is incorrect, or let's say the bond is underpriced, but the option is heavily overpriced. So that way, if I sum them up together on a net basis, I get a value of V1, which is very, very close to what I am getting V2. But there are errors in the valuation. That is, if I split them up separately and I compare them, I can see large differences in valuation, something which is not acceptable. So whenever a client gives you such a product, always insist on them that can you provide a bifurcation of these things. So if they have it, they'll definitely provide it. If not, then you can request them if they can provide it. If not, worst case, finally you have to use V1. But generally that will not be the case because client will have their own valuation agents who can give this bifurcation. So always ask for these numbers so that you have this inputs from client. So we have, let's say, X1 and X2, and you have us. So let's say our valuation. I call that as us. So let's say Y1 and Y2. And then we can combine them together. So that way we combine X1 versus Y1, and I compare X2 versus Y2. And in the end, finally, anyways, we are going to compare V1 versus V2. So this is a given. This will definitely do. But any gaps which we find in this calculation are also to be shown as a part of the valuation report. Because once you say that you're giving a comfort on a valuation number, you should be confident that those numbers are actually in line and they are right both in theory as per any kind of assumptions which you're using are acceptable. So all of these things have to be verified before you issue a valuation report. Because the thing is, now as long as things are going fine, so imagine that you're a consulting firm and you have an agreement with the client to provide this fair valuation number. So as long as all the things are okay from the client side, or if the client's business is going well, they don't run into any regulatory or legal problems, there are no issues. No one is going to ask you why this bifurcation, etc. But the moment there are problems, that is, the moment the client runs into either legal or regulatory issues, and if the regulator or legal authorities start asking for these advanced products data, so because NLD is like a structured product, so the regulator or legal agencies may say that, can you provide us any valuation numbers or reports which you have on such product? Because since these are advanced products, this is something which we would want to verify as a part of our overall legal process or legal or maybe regulatory process. So at that time, if the regulator notices that there are discrepancies in bond and option pricing valuation, then questions can come back to the valuer asking that, did you check this as a part of your exercise? If not, then why not? Now, all these things are something which you want to avoid because these are very uncomfortable questions to answer, especially at a later point in time once that project is already done. So what I would suggest is the best way, or maybe the safest way to do this do is to show these valuations component wise, give the comparison. If you see discrepancies, explain them that, or explain it in your report that such discrepancies exist, and then maybe of course you can discuss with the client as to why such discrepancies are there. So either their methodology is different or maybe the inputs are different, etc. So you should try and include those reasons as well as a part of this valuation differences and include that as a part of your report. Once that is done, that means your report is complete in its entirety. So that way, any questions anyone has, that report should be self-sufficient. So be it a regulator, auditor, or any legal authorities, even if they have any problems, your report should be self-sufficient. So questions should not come back to you later as to why you have done something. So that way, try to structure your report in such a way. Of course, now getting that report to this level in the very first time is not possible. But for that, you have your seniors in your respective offices to guide you. So your senior managers, directors, partners are there who have been around for a very long time. So they'll be able to guide you as to how you can structure your report in a proper way so that uh, all of the queries, whichever they may come up, get answered by the report itself. So something which I've observed and done in the industry, so I thought I should let you guys know. Okay, so going back. So do we have some time? Is it 11:30, 11:35? All right, so we can stop at this point today because the next section is on finite differencing. And for finite differencing, I would want to do it in continuation because we'll see what the finite difference methods are and then probably do some hands-on of that as well. So before we do that, and have you guys used VBA at any point in time?
No,
Excel
sir,
VBA.
not now. Not now, sir.
Okay, but in the past, have you guys used it?
No, sir.
Sir, not as a part of this course.
Okay, okay. But you guys are familiar with programming, right? So at least you guys know R programming, R and Python.
Yes, sir.
Yes,
We know
sir.
R and Python, sir.
Okay, excellent. That way, I mean, even doing a VBA is not very difficult. So that way, since we are doing this thing in Excel, we can just extend this for VBA also. So maybe in the next class, what we can do is we can maybe spend about half an hour for doing some quick things on VBA before we do our hands-on on finite differencing. So that is something which you can try. Of course, now before we start with finite differencing, I'll give you an idea of what is finite differencing, why do we do that, etc. Then we'll see how you can uh, convert a partial differential equation into a difference equation because that's why the name is finite difference. So we'll talk about that in the next class. And before we do the hands-on, maybe we can do some simple activities in VBA so that you get a hang of things, and then we can apply it for solving a partial differential equation, so that you know how exactly things happen in practice as well. Yeah. So before we depart for today, allow me to take your attendance.
Excuse me, sir.
Yes.
Sir, could you please share your PPT with us?
Yes, yes, of course. I'll do that. So I think the first couple of PPTs I've shared. So anything after that, I'll share it tonight.
Sir, Excel sheet also, please, if you could.
Sure, sure. We'll do. Yeah.
Thank you, sir.
Okay. Let's quickly. Okay. So starting with financial economics, Akash Singh is present. Achal Jain is present. Ayush is present. Adesha Hathi,
Present, sir.
Tejas Akware,
Present, sir.
Ali is present. Anjali Garg, Anmol Sen, Arismita Deka, Avni Mishra.
Sir, she's present.
Okay. Ayushi is present.
Yes, sir.
Sarvesh is present. Bhavya Dang, Cherry Chabra,
Present, sir.
Diksha Chauhan is present.
Present.
Dipansha Singh.
Present, sir.
Okay. Gaurav Kadam,
Present, sir.
Gaurav Datir,
Present, sir.
Himanshi Verma is present. Jaideep Sani is, I think Jaideep is present, right?
Present, sir.
Yeah. K. Ayushi,
Present, sir.
Riya Shukla, Priti Marwa,
Present, sir.
Mansi
Sir,
Singh.
Riya Shukla is present, sir. I'm sorry.
Okay, okay. Mansi Singh, Mansimran Arora,
Present, sir.
Manvi Kukreja.
is present, sir.
Okay, okay. Manvi Kukreja,
Present, sir.
Mihir is present. Muskan Garg, Namrata Gaur,
Present, sir.
Neil is present. Nikhil Agarwal, Asul Sharma, Pratik Maheshwar,
Present, sir.
Rachit Tyagi, Rahul Ghosh,
Yes, sir.
Rahul Giri.
Sir, Rachit has some connectivity issues, sir.
Okay, Rachit is present. Okay.
Sir, Prasoon also.
Soon is also present. Okay. Rahul Giri, Rahul Goswami,
Present, sir.
Ajatya Singh is present. Rashi Jain is present. Rishabh Kothari,
Present, sir.
Ruma Keshri,
Present, sir.
Sahaj Manocha, Samiksha Chopra is present. Charanya Bhattacharya is present. Shubham Jain is present. Shubham Kumar,
Yes, sir.
Someshwar Verma, Stuti Mehrotra, Sanika Thakur,
Present, sir.
Vinay Pawar. Financial economics is done. I'll quickly take the attendance for international business as well. Ayush Sharma is present. Alisha,
Yes, sir.
Alisha,
Present.
yeah, Alisha Gupta. Vidhi. Yeah, yeah, Neil Dar is present. Yes. Yeah, Neil, I've marked you present. Anant Jain. Anish Dhopeshwarkar. Anjali Sethi.
Present, sir.
Arshada Imam.
Present, sir.
Barkha Israni. Bhavya Patel. Saloni Bhujbal. Petra Tirodkar. Devam Pandey.
Present, sir.
Diksha Kalra. Auraja Nevatia.
Present, sir.
Gayatri Narkede. Govind Mittal. Sawan is present. Himanshi Virmani is present. Indu. Ishita Saxena. Kanika Goyal. Karthik Mittal. Asro L. Akshay Singhal.
Present, sir.
Mahi Rajawat. Mansi Gupta. Mathagi Warrior. Mega Parak. Nancy Halawat. Neha Jain. Nisha Pradhan. Rohan Bagai. Rohit Poddar. Samida Malik. Shivangi Samwal. Simran is present. Srishti Verma. Anu Goyal. Tarang Kadyan. Kalyani Todkari. Twinkle Karnawat. Vaishnavi Shotriya. Vanishka Jain. Vibhor is present. Vidushi Rana.
Present, sir.
Present. Yeah. Yash Mehra. All right. So thank you very much. Thanks for joining in.
Can you please mark for Prasoon in
Yes.
FP?
Yes. So you're from International
Financial.
Financial. Okay. I'll mark you. Yes. All right. So thank you very much. Thanks for joining in and have a good day ahead. And
Thank
I
you,
look
sir.
forward to meeting you on Wednesday at the usual time, 9:50.
Okay, sir.
Thank
Thank
you.
you, sir.
Thank you.
Thank
Bye
you,
bye.
sir.
Thank you.